I'm Simon, also known as Polyhop. Today we'll be using Bullet Solver and TDAbleton to create this mouse-based interactive in TouchDesigner. We'll touch on the bullet dynamics operators, render picking, adding visual effects, and finally triggering audio in both TouchDesigner and Ableton. Before we begin, I want to thank all my Patreon supporters and give a special thanks to my top supporters. On Patreon, you'll gain access to exclusive example files and tools, can vote on future tutorial topics, and more. So, let's get started. So this project uses a component from the palette as a jumping off point, specifically the multiTouch project here. It's an example that combines the Bullet Physics library, which is the Bullet Solver component here, and actors, with the render picking DAT, or render picking as a concept where you can add kind of interactivity to a render where you can get information about the object that you're actually clicking on and then do something with that information. So these are two concepts that I think are really great and applicable in a lot of situations, and this one example not only uses both of those, but is sort of a nice jumping off point for this project that we'll then add audio to eventually. So before we start modifying it too much, I want to jump in here, talk about what's going on, and then also as I go, I will clean things up a little bit too after I've talked about what things are. So first off, let's kind of make it so we can see this example to the right while we work. So I'm going to hit Alt left bracket. That's to split the left and right panes, and then we can click this drop down and choose Panel or Alt 2. Now we need to make sure we're in the right location as well. We need to be inside of multiTouch. And now we have our interactivity on the right. I'll move over a little bit. One thing you'll notice is there's a little swap button here. This swaps between two different examples. We're not going to look at this one, but it does allow for kind of two control points where you can pinch and kind of adjust the orientation of these objects, these image planes. So another one to check out, but we're going to focus on the multi-touch example here. So we could also, while we're at it, we don't need this swap button and we don't need the multi-pinch. And we will want to say in this execute start create, this resets our system on start. And let's just remove that line referencing swap that we just deleted. So now we're good. Great. Jumping into multi-touch and closing the palette for more view here. There's a lot going on, and some of this is unnecessary, but let's kind of start digging through what's happening here. So let's see. We'll start here at the top with the Bullet Solver. So I mentioned this is the Bullet Solver comp. There's a lot of great examples and operator snippets where you can get more information about how this works and a lot of examples that show different techniques. So I won't go too much into it, but the main components of a Bullet Solver system is the Bullet Solver comp, which does kind of the simulating. You point it towards actors and forces, and then it has some large scale, like top level parameters like gravity. This one's set to 2D, so it's interacting on a 2D plane. There's some kind of initialization options where you can initialize and restart the simulation. And whether it's playing, whether it's always simulating, which is kind of like always cook. So all things to play with, useful. And then we'll have actors. So these are our X-Touch actors or multi-touch. And so each of these, has inside of it, there's a geometry that's set to render. So this is the collision kind of geometry. And then in its general tab, we can actually initialize that specific actor if we want. we set things like whether it's dynamic or static. So this box, for instance, you'll see is set to static. That's the kind of what everything is bouncing around in. And then these multi-touch objects are dynamic. You have options about the collision shape. So these are set to bounding ellipsoids. Things about tolerance. In the actual bullet drop down, there's controls for friction and restitution. So higher restitution will mean it bounces more. Usually you want this on for things like, these objects, you don't want them to fall through the box. So continuous collision detection will help avoid that. Similarly, the box has its own, friction and restitution. So if you want it to be really bouncy, you make that like 2, and then it just like ricochets off the wall like crazy. So we could bring that back down. But anyway, some different settings here that adjust the behavior of the system. So looking here, we also have, this is something that Derivative built in where you can choose the SOP for the collision. So if I wanted them all to be this super quad, I'd drag that into SOP. I would want to reset the system too. So I can click the little reset here or run reset _ toss2d, which resets the simulation. And now it'll be initialized with our super quad, which is also the shape I'll use, for this example. So there's some readmes in here. We can delete those because we don't need them. Another thing to note is impulse forces. So these are not really being used in this example, but they do actually show how you can connect forces to this system. So for instance, impulse force, I can click pulse for impulse, and it's adding 10 units of force in the X direction. So sort of interesting. I don't know how this one was configured, but if you want to just, these are both forces. So this one you might be able to just, I think these are just left around from experimenting. So we don't technically need those. I can delete them. Similarly, this reset is being kind of referenced in the render picking. It's a cool example if you want to see how it works, but we don't necessarily want that in our example. So I'll remove that as well. We will want a separate way to reset this, which I'll set up later. So yeah, here's our sort of, I'll organize these together, our Bullet Solver objects. We'll see that there's this like ipars scene that's pointing to everything. And these are actually internal parameters. If we go up a level under extensions, you'll see there's this like object. It's pointing to ipars scene. So this is how they've set up those parameters here as internal parameters, and you'll see those referenced when they want, say, like TX and TY, which you'll see track with my mouse when it's interacting with this panel. We can quickly get to those with ipar.scene.tx. You'll see it's like right here in the render picking callback. So this is just a way to kind of declutter, I think, instead of having all of these exposed on the top level, if they're really only used internally, you can set up this internal parameters. So I don't actually do this super often, but it is something to know exists when you see it in other people's projects, and how to work with it. Cool. So the other things that are happening here, there are finger timers. So this is technically set up to work with, up to 5 fingers on a multi-touch surface. And as you hold each finger, I can only demonstrate with one. You get these little timers that count. I technically, I don't really need this either. It's a cool example. And, maybe useful information for debug if you've got, you're working with multi-touch. Now, if I just go ahead and delete this, it will give me some errors. And I don't remember where that does that. It's probably in this one. Yep. So it's giving me some errors. If I hit Alt-T, it's giving me some errors on line 11, and that's because it's, doing some updates to finger timers. I deleted it, right? So it doesn't exist. So I can actually just remove those lines here that mention finger timers and no more errors. Great. So we've started cleaning up a little bit. Some other things like this README is just telling us information about the system. So it's an interesting note. It's actually that these cursors that you're seeing are actually containers, right? They're being positioned and drawn on top of the main panel. So they don't show up in our render or our render pass, which, you know, a cool technique so that you can kind of overlay mouse or finger information, but also you can't really add post effects to that without, say, adding an OP viewer or something, and it adds like another step to the render kind of flow or chain. So I am also not going to use these. Definitely kind of interesting, and I have used this technique before, moving and kind of animating the position of containers and layering those, but I think for our purposes we're not going to do it. So I'll move that up here. You can also maybe, like, this kind of helps clarify what's going on, is to just reposition our layout origin for the replicator. You can see here's our master cursor and our cursor icon, the README. And then it's being driven by these interactors using an OP find to find all of our multi-touch objects. So there's one cursor per object, right? There's cursor 1, cursor 2. Now, when I first, was mucking around with this and I deleted this because I thought it was only being used with the replicator, I later figured out, oh, it's actually being referenced in reset toss as well, which is our reset function, running this with Control R. Resets everything. So yeah, don't delete this if you want the reset function to work. We don't need any of this, however, and luckily nothing is dependent on those. So deleting those, everything still works. We just don't see the cursor currently, which we'll eventually add one. So okay, it's looking a little bit less cluttered. That's great. Kind of the needs to know, like the, must-haves are what we're keeping. For instance, this button that says Show Interface, it just pops up a second window. You can look inside. Okay, there's a panel execute. It opens the window when you press the button, which, I don't really need that, so I'm going to delete it. Similarly, this OP find just seems like it's like vestigial. I don't think it's needed, so I'm going to delete it. We can see there are some render picks down here. So this is here's some of our render picking items, and I'm going to reorganize those slightly. So we have a camera, a light, and you'll see we have our render 1, which is showing us our kind of main view here, what we're seeing, and then render pass 1. So render 1 and render pass 1. Render pass 1 is only rendering our plane and clearing the camera color and the depth buffer. So we're only seeing this grid. And why that's useful is it essentially means that's the, when I use render picking, we're feeding in the UV. These are normalized coordinates of the mouse. And when I click, you'll see the select toggles 1. So select, U, and V are really the, there's other information, but those are like the 3 most important pieces that you feed into a render pick DAT. With those 3, you can get information, say about, like right now it's telling me the path of the object that I've hovered or clicked over. This one's set to always, so I don't even have to click. Like I just hover over it, and it's giving me the TX and TY position. This is like the world position, right? Of like in this sort of geometry space, going back from our our rendered screen space here. So it's a cool conversion. It goes back from this coordinate system UV to XYZ. And this position then can be used. You see here, we're taking that position, e.position, which is the event. So the event position, and setting our internal parameters scene tx and ty. So you'll notice that when I'm hovering over the screen, the world space position tx and ty is changing. So that's useful. It tells us like we can use that to interact with our actors and things like that, which we'll look at how that happens in just a second. So that's what this first one's doing because it's pointing at render pass 1. Render 1 is doing something different. This is telling us which of these actors we've actually clicked on, if we clicked on one at all. So you'll notice that of the kind of things, the geometry that I'm rendering, which these actors work as geometry, some of them have pickable toggled and some don't. So that's why this little orange dot exists. It tells us what things were, if we click on them, show up in a render pick dat or chop if you're using the render pick chop. So if I actually turn on box, luckily this doesn't break anything, but you'll see now, actually it tells me, oh, I'm clicking on multi-touch box out 1, which is the geometry. I don't need that, so I'm going to turn that off, but it's just a good example so you can see like why that exists. Another kind of thing, I might have deleted the README that talked about this, but it does note that it's also using tags, and you'll see that in these callbacks here, if not grabbable in geo.tags. So another just thing to note if you're modifying this system or other systems, sometimes they use kind of less common techniques like tags. Okay, so a couple things here. You can dig into this a little bit if you'd like further. I don't want to spend too much time on it, but because this system just kind of works and we don't have to modify it for our example. But it's worth checking out because it at the bottom here, this is like all the information we can get in our events when you click on something and like have selected an instance or geometry using the render picking. And they're using quite a bit of this. Anytime they use e dot, they're referring to one of these pieces of information. Things like the start time, the end time. So they can use that to set things like, okay, are we dragging the geometry? How many touches if we're using the multi-touch? Where did it, what was the U and the V coordinates when we, the down U is like when we initially clicked it. So it can use that to calculate kind of the differential between our current position of like the cursor, for instance, and where it needs to go. So all of this stuff, is happening here in this render pick callbacks. So some other things here. Then we can actually see this happen if we say look at our actor, and while we're dragging it, you'll see, oh great, it's turning drag on. Number of touches is 1. We have our, if I click and don't move my mouse, down U and down V will be the same as U and V, but as I move around, you'll see U and V changes. So useful thing to kind of see in action. And then beyond that, if we double click on our X-Touch 1, this is our this is the clone master. So all of these are clones. If we change anything we want to do in X-Touch 1. So we're getting our parameters, our specifically custom parameters, and then grab is where the magic is happening. So this is another key thing with the Bullet Solver, and there's good examples in the operator snippets. If you look at the Bullet Solver operator snippets on this, but the Bullet Solver chop gives us a lot of information about the position, rotation, the velocity, the rotation, like the angular and a velocity as well, velocity Rx. So we're just getting the position from this. Tx and Ty is what we care about in this simulation, but it's a lot of information you can get about a specific actor. And then beyond that, at the end of this chain, you'll see bullet feedback. And if we go up a couple levels, there's this bullet feedback chop where we can kind of manipulate values. Usually, like in this case, we're manipulating the velocity. And I would say you almost always want to do that in any kind of bullet solver example. Otherwise, things get really weird and kind of glitchy, where manipulating the velocity, you can say push objects towards a target position. And that's how we get this kind of nice springy motion. And it's happening here. So again, I don't want to go too deep into this. You can dive a little bit deeper, but what we're seeing here is we calculate. Oh, let me grab one because we'll actually see it happen. So as we click it, it comes up with a desired position, and at the beginning those are almost the same. But as I move the mouse, it's determining like a corrected position, and then eventually using that to say like, okay, how's that different from where I started, or where I currently am, right? So this top one is where I want to go, and this bottom one is where that object currently is, right? And then this desired displacement, the difference between those positions is the velocity that we want to eventually kind of, in this case, we're crossing it with our the velocity of that object currently. So you're kind of like mixing in this target position, right? And you'll see here, like as I drag longer, so the longer I've clicked it, the more it crosses that velocity. So that's how you get kind of an interpolation between the current velocity and our ideal velocity, so that we eventually are just using kind of like our target velocity. And so then we use a replace to swap out, our modified velocity, delete all the things like position and rotation that we don't want to send back into the bullet feedback, and send that out. And then this is what's then selected in our actor. So yeah, a nice way to, these kinds of chop feedback systems can be a little bit tricky at first, but I mean, this is an example that's kind of got a lot of nice features you can pull on for more complex stuff, extrapolating this to 3D or what have you. Okay, so I think we are close. For the most part, we've got everything here cleaned up. So I think that we will jump into actually making some modifications. I'm going to just clean up some. Oh yeah, these two also. We don't need these. These are also superfluous. And I'm just going to scan through this. Yeah, the other thing, we don't need this additional multi-touch in 2. It's set to a different mode, and it's not doing anything right now. Okay, yep. This all looks good. We'll go ahead and save this and then continue. Before we jump into making some aesthetic changes, I just want to go ahead and add a keyboard shortcut option for our reset toss 2D function here, which if I hit Control R, resets the simulation. That's pretty handy to have on a shortcut. So let's do this with the keyboard in DAT, which I'm using more and more for keyboard shortcuts. Might even be a good option for a tool at some point. So let's go in here, and you'll see that at the top is all this information about what is provided. So we have key info and DAT. That's just the keyboard in DAT, but key info has key, which is the name of the key, and then followed by all of these modifiers. So I can go ahead and say, okay, well, if key info dot, I want it to be Control-Alt-R. So Alt is true if the Alt modifier is pressed, and key info dot control. So Control-Alt, and in this case, let's do the key info dot state. So this is important because otherwise we'll get on and off events. So we just want this to do it once when we press the key for the first time. And then now anything I want as shortcuts I can put here. So I could say if, keyinfo.key equals R and do my thing. I don't, this is the only shortcut we'll use, but this is also a good option for sort of a match case scenario, like a switch statement, but in Python, where we could have a bunch of different keys and do things, and it makes it pretty readable, and you don't need a lot of like keyboard chops all over the place. So let's go ahead and just say this one was called reset, like toss. I have to look at what it's called. Yeah, toss 2D. Cool. So yeah, op reset toss 2D dot run, and that should be all we need. So I hit Control S. It's right here now. So now let's see if that worked. If I hit Control R, yep, worked. So that's just a nice little initial kind of quality of life change. All right, let's add some visual flair to this. So let's go up a couple levels. And I want to start by changing the width and height to 1080 by 1080 just to get a square aspect over here. You technically don't need this like nested container. This situation is because there were those two different containers in here before. We'll leave it for now and just manually type in 1080 by 1080, but you can always move this outside. Eventually you just might need to reload the project. Sometimes it doesn't like just being kind of pasted outside. The other thing we need to do is change our render resolution, and I will go ahead and bind this to the parent in this case. Parent.pair.w and h for the width and the height of my parent component. The nice thing is it all still works because we're using this render picking setup, so as long as the camera stays the same, all is good. This is using a like this focal length aperture setup. I usually use horizontal field of view for my camera, and then we'll set this to 45, which is the normal default. We'll zero out our rotation and zoom out a little bit so we can see the full box here. I also am going to change the box size to 20 by 20 so it is a square. And we don't want to actually see that box, so I'll also, while I'm at it, just remove box end. We no longer have reset. So we're only seeing our multi-touch objects over here. We'll create a new background. We do need to leave the box here. If we turned off render, the Bullet Solver would see that as us like disabling it. So keep the render flag on, but just don't draw it is the solution. Let's also go ahead and for now we'll just use a constant material for our actors. Later we can make it look more interesting with post effects, but I'm going to go in here and we're going to remove these materials. It's not going to be happy for a second. Actually just use this as the default Phong. Set up a constant material. I'll use a null here just in case you did want to change it later and call this matte to make it easier to route it in the future. And then under render, we'll just type matte instead. So they're all constants. It's not happy because there's this like texture parameter in config. You could just delete the reference there, or You could even remove that in customize if you want, but we'll leave it for now. Jumping back in, the other thing I don't need is like, I'm not using this switch here that when I'm dragging it, it makes the point color green. So we can just also delete that. All right, and then let's add a background grid. So the next thing I want to do is, so that I can create a background that is kind of separate from our objects, I'm going to use render passes. And I also want to add a foreground, like kind of like, redraw the cursor with some other graphics. And so I will also create two render passes while I'm at it. I'll create one for anything that's called foreground star. So anything I title foreground will show up in this render pass. Disable the camera color and depth buffer, and then I'll add another one of these inline, right-clicking to do that. And this one we will do BG star for anything that we title background, also clearing color and depth buffer. Yes, so let's go ahead and make our grid, is what I was using for the background here. And I'll right click and add this to a geo comp, and we'll title this BG grid grid for background grid. We also want, I can just use a constant here and set this to wireframe, topology wireframe, and I'll up the line width a little bit. I don't want it to be totally white, so maybe 0.6. Can adjust that later, and then we'll set it to the same size as our box. Later you could always pull some of these parameters out later to link them, but for now we're just going to hard code those values. And you'll see that it's showing up in our render pass 3, which is our background geometry. So I'll combine this with our output now. I'll use a composite and add. I know that later I'll be throwing some other things in here, and so we just want to be able to add together all of our different layers. And one other thing that's happening in the effect is I am using the edge just to give myself this kind of like edge look for the objects. So the next thing, we can go ahead and add the custom cursor. So I'm going to use a cross for this, as in two rectangles. So first I'll create a rectangle SOP. This is some buggy behavior in Touch, but you can just disconnect that. Yeah, I'll right click to add a geometry comp, and I'll call this FG cursor for foreground cursor. It is getting rendered in render pass 2 now. And because I want to see this, I'll just drag that also into my comp so I can see what I'm doing. Now, so that we can make it a cross, let's just make it a little skinnier in the Y size. And we can use a copy SOP, 2 copies, and we'll rotate it by 90 degrees in the Z axis. And now we have a cross. Maybe I make it a little bit skinnier, and then I'm interested in this being like, I don't know, pink. You can make it any color you want, keep it white, what have you. Now we want this to show up at our cursor, and you'll notice that this is our cursor position here, TX and TY. So we can actually use that same internal parameter, iPair.scene. Oh, if I can type today, .tx, and that gives us our x, and then just the same thing for ty. So we have it moving around, following the cursor. Great. We also want the kind of like cursor to fade in when we click. That's one of the things that the previous examples kind of containers did. And I'm going to just design this to work with the mouse. So if you want this to work with multi-touch, you're going to have to build this a little bit differently. But we are going to use the parameter chop to access the grab state of all of these. That's actually how the other example did it as well. And we can do that in one fell swoop with the parameter chop by just typing, I think it's xTouch, right? Is that what it is? xTouch star. Yeah, so that's giving all of our multi-touch actors, and the star is a wildcard, so it's pulling from all of them. And we just want the drag parameter. So in that drop down, we can choose the parameter we want, and now it tells us which one we're dragging. Now we don't really care, we just want to know that we're dragging any of these. So I can combine these with combine chops. Let's do maximum. Combine channels maximum. We only have one chop. So now it's going to be 1 anytime we're dragging one of these actors. We can also add a lag to this. I sometimes use filter, sometimes lag. Lag has slightly different behavior. So if I set this to 0.1, kind of get this like ease in, ease out slightly before and after. And then, yeah, now we have our opacity. So I might rename this just for clarity, opacity, and add a null. Also call this opacity. And now I can drag this right onto alpha and use a chop reference. Boop. So it pops in and out. Real nice. I also want to add a little dot at the position of the one that I'm selecting and a line between them. Also in the foreground, I'm going to move these out of the way a little bit. So for the dot, let's add a circle, SOP. Also right click and add why did I do a base? Oops. Right click and add a geocomp. This we can call foreground underscore object, and I'll use the same material. Let's make it a bit smaller, 0.1. That's, yeah, we can always make it bigger. And then this is an interesting one. We want the position of the currently selected multi-touch. Now, if we look at our render pick 1, we are getting this right here in this first, well, it's row 1 path is the column. Whenever we select one of these, it's saying, oh yeah, this is a xTouch 3, this is xTouch 1, right? So we can actually use this path. Technically, it's pointing at render. So we want the parent of this object, of this operator. And then once we get to that operator, we also need to know its current position, which is not happening at the top, right? So this is something that we want to go all the way into grab. It's a little bit deep here. It's the bullet solver is getting the real-time position X and Y, and that's where we want to draw our dot, but only for the one that's being selected. So how to do this? Let's first select, we're going to select the chop, the bullet solver chop for the operator that is being shown in our render pick. So we can do this in one Python expression right here in the chops dropdown. So let's see. First, we want OP render pick. Is it just called render pick? I think it's called render pick. Yeah, it's just called render pick. So we want render pick. And then within that, we want to access the first row and path. Now, if you recall, this is one layer too deep. So we actually need to say, okay, actually take this operator, right, and get its parent. So this is now pointing at the selected xTouch or multi-touch actor. It's not a chop, so even, doing this, it's like, oh, it has to be a chop. But at least it tells us like we've got something, right? And so the next step is let's get the operator within this operator which is the bullet solver. So that's .op, and then we want grab / bullet solver. And yeah, if we do this, here we are. So it's good whenever we select one, right? This is getting 5, 1. But if we don't click, if we click the background, it's a little bit mad because this doesn't exist. So the other thing we can do is kind of use a conditional here to say, well, if this doesn't exist, if it's empty, right, don't do anything, right? Just don't select anything. So we'll say, okay, all this, if OP render pick one path, so if there's something there, else space. There you go. So now anytime this is not like returning, true, you just draw space and it doesn't select a chop. From there, we also want to make sure we're just selecting TX and TY. So under channel names, T, X, Y. And then for good measure, because also sometimes there's nothing here, let's go ahead and create constants. So here's a constant. I'll go to snap and pulse, and then just set these to 0, though it doesn't really matter. This is our kind of like dummy values. So we'll use an override. And now anytime there's something selected, we'll get our values. Otherwise, nothing happens. It just still gives us values, and that'll avoid errors. It'll still work, but we don't want errors. So object is this null, and we'll use that for our translate. So now, there you go. Draws like a little dot. It's got a little kind of like lag, but I think that's sort of interesting that it's not exactly centered. I think that's from the whole feedback scenario that's happening. So the last piece of this is we can just draw a line. Now, I don't really recommend doing this a ton, but if you just need one line, it's not crazy to take a line sop and cook the point A and point B. So you can do this a little bit. I think if you tried to do this, thousands of times, it's going to get pretty heavy on your CPU, and that's why you'd use instancing or something like that to position them. But if it's just one, like in this instance, then it's easy enough to say, okay, let's take my ipar.scene tx and ty for point A. We can grab our object, just export that as a reference for point B. And now this is, you can see it's kind of following between the two. And here I'll use a line. Could also use a constant set to wireframe too. I think that would work as well. Set this to material. We're going to drag opacity and export that to line near alpha. It's a bit of a tongue twister there. 9 leer. Chop reference. Don't specify a different far color or opacity. We'll set this also to that kind of pink value. And then it needs to be named appropriately as well. So foreground, could just call this line. Hey, there you go. Cool. It's giving us a warning because blending is not enabled. And also this is giving us a warning because of like a transparency, potential transparency issue. You can set this to alpha to coverage and it'll go away. Though, yeah, then you at least don't have that warning there. And now we have that fun little line. We could maybe make it a little thicker, like 4. Yeah, cool. So yeah, we have our cursor and like kind of UI elements there. The last things we can do here, I have, in the example, I set up a sort of kind of like a feedback displacement effect with the grid, which adds these kind of displacement trails as they move. So for this, we're going to need both our render one and our grid, which is our background. So I'll middle mouse and add a base, and I'll call this grid warp. And we'll jump in and add another input here. And then instead of using render pass 3, so I'll disconnect this one, drop in grid warp, and then our out for now will be our grid. So we'll do the work in here. Let's make a feedback loop. So we'll add a feedback top, and I'm going to use over as the way to combine these two. And my over, I want to set, I'm going to go ahead and use this to set my pixel format to 16-bit float. That way we will get, you know, a nice fade to 0 and not have values that get stuck. So we'll add a null. And then within our, that null can be pointed at the feedback. So we have, here's our loop. And we want a blur. And we'll set that just to 6. It really doesn't matter, 6, 5, whatever. And a math. So this is our like decay. So kind of like smoothing out the trails, and then also we'll go to mult add and just do 0.99. You can adjust this to kind of change the quality of these trails, but you should see yeah, the most basic feedback ever, basically. But we're not going to actually show this. We just want to use this as our source for displacement. So we can throw a slope on here. Can't really see much, but if I hit A and N, you'll actually see, yeah, there's sort of some edges there. And then maybe I'll make that 2 a little stronger. And we can also add a displace top and just drag this right in. And the handy thing about slope is actually like pre-configured to work with displace. Like I usually have to change this to red and green for a lot of other purposes, like optical flow, and you know, if this is your X and your Y, it's usually red and green. But slope, you know, blue is our vertical luminance and red is our horizontal by default. So usually just works out of the box. And there you go. We've got this kind of like, you know, fun little effect where also like the actual path, because it's usually pretty solid colored, like it has this kind of interesting trail where you get the clarity of the grid within it. So yeah, it's, you know, you can play with this how you want or don't use it, I don't know, but just a little displacement effect. And then last I added a bloom, and we need to dial this in a little bit. So maybe drop the pre-black. Maybe the radius comes down a bit. So we're getting kind of like more of a neon look. I don't know if this is exactly the settings I had, but you can adjust this as you like. And then there's some like if you look closely, the edges get a little bit funky. So you might also want like an anti-alias, which can kind of help clean up some of the artifacts from this warping. Totally up to you, but this is a, you know, good steps towards adding some post effects. You know, if you really want to get kind of wild, you can add some like RGB delay. There's some of that in the palette here. There's a good warning about this actually, is that that's RGB blur. RGB delay. You know, one thing that is kind of a gotcha with this is that it's kind of preset to always cook. So you'll notice that cache 5 is set to always cook. So this can actually throw off your network if you're not careful, because even if you like pause the network, it'll still cook. Or if you're trying to make loops with it, it won't necessarily work at the beginning and the end, because yeah. So I always turn off that. I actually have versions saved that don't have it. So yeah, this is kind of a like gives you a little bit of a slight kind of I don't know. I don't know if I like it that much, but use it tastefully. Anyway, those are some different options for post effects there. So yeah, we'll look at how to make this sort of like blink when it collides with the walls, and then after that, or other objects, and then once we get the visual stuff all down, we'll look at audio. Next, let's go ahead and add some flashes when these collide. So to start off, we'll go ahead and jump into our Xtouch 1. We'll create a series of chops here, and then eventually trigger that with Python. So we'll start off with a trigger chop. Let's set the attack to 0, peak length to 0, decay to 0, sustain level to 1, and release length 2. You can adjust this if you'd like, but essentially this is our envelope for our flash. We can see what it looks like by pulsing it. I'm going to create a math and call this brightness mult. We'll use this later to control how bright the flashes are based on the velocity. And I will also create a null called state. I'm going to color this red just because it's a null that I'm going to reference later. And this we'll use to make sure that we're not triggering this when it's already in the process of a trigger. And this is important somewhat for the visual, but mostly for audio, because we don't want, like, if it repeatedly hits another object really quickly, we don't want it to be triggering sounds repeatedly. It won't necessarily sound good. So yeah, the next thing we'll do is add a math, and this we can use to set the low and the high range for our background color. So I'll set this to 0.1 and 1 so that it's always going to be kind of like have a little bit of fill to it, and make a null, and then just drag this and chop reference. So we need to make a couple adjustments to our edge for this to work. So one thing to change is use our alpha to calculate the edge instead. And then also we will comp over our input. So now we have that dark gray, and it actually shows up a little bit with our bloom, which is fun. And now if we go ahead and click trigger pulse, we get a nice bright flash for our Xtouch 1. So we'll use this to trigger each of our corresponding actors. The next thing to do, we actually are missing something here that's usually there for our Bullet Solver to get some additional information, and that is the callbacks. So if we go ahead and create a Bullet Solver, it comes with this DAT that runs various functions based on what happens in our solver, and one of those is on collision, which basically anytime there's a collision of actors, we run this function. So we can use that to actually do other things based on the behavior of our solver. So let's undock this. Hello, undock, move it over, delete that Bullet Solver, dock to Bullet Solver 1, and then the last thing is we need to drag this into callbacks DAT. Otherwise, this Bullet Solver doesn't actually know it has any callbacks. It doesn't until we do this. So now the last thing is anytime we make a change to this, we're going to want to just reset the simulation, like reinitialize it. Without doing that, which I did the Control-Alt-R keyboard shortcut, it won't, like, our changes won't, go into effect. So if it doesn't work for you, just remember, maybe, make sure you've reset or reinitialized your solver. Okay, so let's go ahead. I'm going to hit Control-E to edit this in Sublime Text. And a couple quick notes at the top. This is all really good info. First off, it's telling us that solver comp is our Bullet Solver comp in case you want information from that. And then collisions is where the magic is really happening. This gives us a set of body A and body B to Python body objects. And so this is the first and the second body in your collision. And then if you want more information about this, check out the docs.derivative.ca/body class, which tells you a whole lot of information that's stored in these two bodies. We'll be using the linear velocity, for instance, but you can get information about their position. You can set that information if you want to move them to a different spot. So this is super useful for manipulating your solver with Python and getting information from it. So here's our onCollisions function. And for the sake of just keeping this clean and avoiding errors, I'm going to be pasting in lines or blocks of code and talking about them. So you might need to pause at times to type things out. I do think that typing out yourself will improve the learning process, though you can also check out the example file on Patreon as well if you find that tedious and you just want to manipulate the existing code. So yeah, let's go ahead and we're going to first store our collision bodies. So collisions.body A, collisions.body B for body 1 and 2. And then the other thing I want to know is the name of my box. Actually, I'm going to split this so we can see what it's looking like over here and reference as well. So that's the my box actor. Now, what we can do with that is check to see what the body 1's owner is. So that's if the owner is, for instance, box, we don't want to make something happen, right? Because the box doesn't need to flash. It doesn't need to make a sound necessarily, though you could, do that. But we do want to do that if it's any of these multi-touch objects. And just for the sake of demonstration, we can go ahead and print, say, just the b1.owner anytime, so this anytime this body 1 collides, as long as it's not a box, it will print the owner. So we can just see what's happening. I'm going to split this right pane top and bottom and hit Alt-9. We can also do that here for the text port so we can see kind of what we're doing. And now if I hit Control-Alt-R to reset the simulation, we see, okay, there's our multi-touch 1 through 5. Now we're not seeing the box anywhere, and actually we might not see it because there's 2 bodies. So even if we place this outside of our if statement, and here we go, comment those out, we might still only see multi-touch because, there's 2 of them. But if we did want to, say, print body 2 owner and reset it, now we're getting a lot of boxes. And so that we need to check both of these, since we might want a sound for both objects and a flash for both objects when they collide. So we're going to need to check both body 1 and body 2 separately. So we'll do that again below. And we can have these then do something, right, when they collide. And so I want to create a function called trigger, which will be triggered when on collision. And we're going to pass in the xTouch, which we'll use to pass in the body itself, the owner, technically, of the body that has collided, and also the velocity. So I want to know, who collided and how fast were you going. And so down here, to do that, let's copy this in. All right, oops, too much. So we're going to call our trigger function that we just created, pass in for our first argument b1.owner, and then b1.linearVelocity, which gets the linear velocity of that body. For the second function here, we can say, okay, we're also going to pass in body 2 and body 2 linear velocity, so the owner for the other one. And that way we can have one function that takes care of both of these. Save that. It's not going to be happy until we finish this, so let's continue. The next thing we want to do is I want some sort of amplitude that I can use to map my velocity, some value, to map my velocity to, say, our brightness. So I call this amplitude, or really magnitude. It's the really just doing the distance formula here, the square root of our first velocity component and our second velocity component, our x and our y values. Since this is 2D, we don't care about the z, and we'll square both of those. Then take the square root. So this will give us our amplitude, and then the next thing, we want to check that a given multi-touch or X-touch object is not in the middle of an existing trigger. And that's what we'll use that state null that we created for. We can create a variable called isActive that's just going to store the value of this state. And so I'll say X-touch, which again is X-touch 1 through 5, and then the operator state and the value of that first sample, and that will be 0. So, or the 0th, channel. So now we can set up a conditional based on whether it is active, and I also don't want, something really slow to trigger. Like if it's moving glacially, it might still activate. And so we can set up some velocity thresholding. And I'll also set up a velocity max so we can map our values, say from 1 to 30. If you want to know what those values are, you could always, like I did this at some point, was printed my amplitude on collision. And we can even see if this works. It's good to kind of test as you go. So if I reset, yeah, we're getting a bunch of values. Most of them are above 1, but some of them are like 0.8. We might want to filter those out. So yeah, we can use this to map our values. If we throw it when it is really fast. Okay, let's see if I can do that. Yeah, then we're getting stuff in the 30s, but I sort of want to kind of cap it, right? So you can say, okay, like what's the range that I want to actually map? Okay, so next let's use that conditional. If my amplitude is greater than my velocity threshold, and if it is not currently active, then I can trigger it. The next thing, I want to pull in a couple functions here to do some kind of one to remap my velocity value or my amplitude, and another one to clamp it. This is very similar to, say, like the Arduino language, if you're familiar with that, where you have an input value, your minimum and maximum, and then your min and max. So this is just a way to kind of remap. It's basically the same as your math operator, like the range, from range to range. And I'm pretty sure I actually pulled this from some Stack Overflow thread, but it's pretty handy and doesn't exist in Python. And then also just a way to clamp values as well. So we take the minimum of the value and the maximum. This will give us our minimum, and then the maximum of our minimum and our previous value. Cool. So with that, we can now come up with a brightness for our flashes. Boop. And so first we're remapping it with that function above. And so we're going to take our amplitude, the velocity threshold, which if you recall is 1, and the velocity max. So those are low and our initial low and high. And we'll remap that to, you could pull these out, but I'm just having these variables or these values kind of like hard coded for now. So that's going to be our kind of minimum brightness for our flash and our maximum brightness. And then I'm going to just clamp that as well. we shouldn't see anything lower than 0.3 because of this first conditional here, but we might see things over 1, right? So that's just a way to make sure that we limit our values. The next thing we want to do is set that brightness, right? So that's our brightness mult that we want to access, and specifically the gain parameter. It always throws me that this is called gain because it's like multiply. It makes sense, but it's not intuitive to me. So it's very like audio DSP feeling. So X-Touch, yeah, we want to take our X-Touch and then the operator brightness mult, and then the gain parameter, and set that equal to our brightness. After we do that, we can go ahead and trigger. That F is an error. There we go. So we'll go ahead and trigger 1 with trigger pulse. So that's the name of our trigger pulse variable, our parameter here, and then and pulse it. So let's see if this works. Hit save, Control R, and there we go. Look at that. We're getting blinks, and it's sometimes triggering this first one. So you can see it in action. That's great. So cool. Yeah, we've got our blinking. That's good. So I think next we will add some audio to this. Okay, so let's go ahead and add audio to our collisions. I'll first show how to do this in TouchDesigner natively, and then we'll look at an example in TDAbleton. I typically would do this in Ableton unless there's a reason for doing it in TouchDesigner, often just needing a license, for instance. But I find usually it's a lot easier to do this kind of thing in Ableton with all of the kind of different audio effects and instruments at your disposal. Sound design's a lot faster for me, but you certainly can do it in Touch, and I think it's useful to know how to just add simple sounds to your TouchDesigner project in a pinch. So let's look at that first. Also, not everyone has Ableton, so it's good to know how to do it in Touch as well. Okay, so let's make a bass. This is called audio TD, since I'll do this audio in TouchDesigner. And I'll jump inside and create another bass, this one called Sampler 0. I am 0 indexing this for a reason, which we'll see later. So just roll with it. The Sampler 0 will house an audio file in, and I'll create an out. And we're going to create multiple samplers here because we don't want, we want to be able to trigger overlapping samples. Say if like 2 of these collide at the same time, we can't trigger them with the same audio file in. So that's just thinking ahead for some polyphony. I'm going to drag the volume down just so that I don't hurt any ears, mostly mine. And then I will select, I'm going to select the out here, and I'll use a wildcard. So I'll say sampler star / out 1. So now if I copy this, paste it, we're seeing, all of those show up there. And I'm going to sum all the channels. Now this is less good if you're using like it's not as effective if you're using stereo. So you might need to split these out. You could just select the 2 channels here with 2 outputs, do this process twice, and then put them together later. But for now, my sample is mono that I'll be working with, so we only need 1 channel. The summed audio here could exceed, if we're not careful with our volume, could exceed 1 and clip. So I also want to just add a audio dynamics, that's it, and turn on the limiter just to be safe. And then you will probably want audio device out, right? So you'll set this to whatever device you've got handy, or what you're using for your audio. I'm going to, for the sake of the tutorial, use an NDI VST. Very handy set of tools there that act as VSTs and let you route audio. Highly suggested. Cool. So from there, let's go ahead and not let this play. Zoop. I'm gonna turn off repeat. We'll only want to trigger this one time. And then let's go to the top level, customize component. Here, I know that I want to bind as new, I just bound the file here so that we can load a sample, and then I'll go ahead and pull in this zap sound. So that's what I'll be using for my samples in TouchDesigner. Certainly, you can use your own samples. This is a pretty silly example. The other thing I do know that I want in this top level is I want an integer called polyCount, which is like how many samplers. I'll make that a section. And then also I want to store what the last sampler was. So we'll change this value anytime we trigger a new sound. We'll keep that kind of up to date so that we know the next one that we want to launch. On our sampler, these we're also going to customize, and I'm just going to pull out some of the audio file in parameters that I want. So for instance, cue pulse, so I can cue it. Also the speed, so we could change the pitch based on how fast it's going, and also the volume, so they can be louder. Bind new pairs master for all of these. Great, so now we've got a set here. We'll go ahead and replicate this now. So drag sampler 0 into master operator. Sampler is the name, it's the operator prefix. We're replicating this by number, and that will be parent.pair.polyCount, which currently is 0, but we can set this to about 10. You'll hear a little ping because they all activate when you create them. And now, yeah, we've got our samplers. View these. We can see that, we can change these independently, and they all get summed and sent out to our audio. Cool. So yeah, we've got ourselves our little basic polyphonic sampler here. Now, the next thing we want to do is go back to our Bullet Solver callbacks. And here we want to add something that also triggers sound whenever there's this flash. So within this if statement, we have triggered our brightness, and below, that's where we want to do our audio trigger. So one thing I want to do before moving forward, a little planning ahead, is I'm going to customize multiTouch, not the top level, but the one that houses the bulk of everything. Customize component and add a toggle here called TDAbleton. Now, we'll leave this off for now, right? But I want to be able to toggle this and then have a version that sends to Ableton, so we can have just one code for all of it. And I'm going to call this in my Python audio source and just grab parent.pair.TDAbleton. So right now that should be 0. And within our if statement here, I'll say if audio source is 0, then we're going to trigger in TouchDesigner. The next thing I want to do is I'm actually going to extend this guy a little bit more with some parameters that we can use. This way we can define on this operator audio TD kind of the minimum and maximum velocity and speed, I guess, or pitch. So I'll customize that component again. These we want to be floats, and both of them should be 2 in terms of their size. And one of them we will call we'll call one pitch range. Drag that to the bottom here. And the other one, volume range, or just VOL range. I can actually put a space here for the label. So you'll notice sometimes the label, our pitch range I did that wrong. I usually try to make my labels nicer. And you'll notice that it always just removes spaces and makes things lowercase for the actual parameter name. Okay, so our pitch range, I'll see if I can remember what I did on here. Probably like 0.2, and maybe we can make it really high, like double the speed. If this will map to our speed ultimately. And then the volume range, I don't know, 0.1 to 6, 7. You can play with this. It's just like how loud the range of volume will be when we map it. Okay, so now that we have those, let's also pull those values into our Python. So first, I do want to point to this operator. So I'll just have audio TD equals op audio TD, and then just grab all of those ranges so that I don't need to type this whole chunk here, audio TD.pair.pitch range. You could store this in like an array or something if you wanted pitch to just be, two values, but this is just easy to read, I think. And then, now we've got those values here, so we can use those later. Now in our audio source equals 0, this is where we want to, first, we want to know like how many, like determine which sampler to queue, right? So we have, 10 of those. So we care about the poly count, right? We're also going to grab poly count. And we want to also know, oops, this is a little bit too large. Our last sample, this will change, right? So we want to know what was the last sample that we triggered. Make a little space. So the next thing we'll do is, now that we know the last one, we can determine the new one. I'm just going to make this full screen for the moment so we can see. So this sampler is actually equal last sampler plus 1, and then mod poly count. So that's partly why we're 0 indexing it, because this mod will give us 0 through 9, right? Instead of 1. So we're starting at 0. And then lastly, we need to update this for next time. So audio td.pair.last equals this sampler. So we'll keep adding 1 and loop around to the top. So now that we have this sampler, which is really just a number, we also need to get the operator, because we have its digits. So sampler op is equal to audio td.op, and then we'll use an f string here, which replaces what's in the curly brackets. This should be an int, but I'm kind of casting it as one for good measure. And yeah, that should give us specifically the operator within audio TD sampler 0 through 9. Now, the next we want to do is set the volume and the speed. I wonder if I called, yeah, that's right, yeah, because our sampler op should have speed and volume here, right? So we need to set those to volume and pitch. And you know what I didn't do is set our volume and pitch yet. So I did this a little out of order. One thing I'd want to do first is actually similar to how we remap our brightness. We can use that same method to remap our volume and our pitch. So let's do that first here. Our volume, again, we're taking our amplitude and remapping it to our velocity. Are taking our velocity threshold and maximum, and then remapping that to volume low and volume high, which we set up above. We'll do the same thing for pitch. Remap it, clamp it, and now we have those values. Cool. A little bit out of order. Last thing to do is to trigger our sound. And we should do that with qpulse dot pulse. And because that's a custom parameter, like you'll notice just refreshing, like those will always be capital to start and all one word, lowercase letters, unlike the built-in parameters. Cool. So let's try this. See if it works. Control S, Control Shift R. Oh yeah, there we go. Sweet. So yeah, it's a little bit silly, but we'll look at a slightly maybe less silly or as silly example in TouchDesigner Ableton next. All right, let's go ahead and add some audio with TDAbleton. So I'm going to assume you haven't installed this before, and let's just start from the top. First, let's turn on TDAbleton, so that'll disable our current TouchDesigner audio for now, and make a new base, and just call this one TDAbleton to house all of our Ableton needs. And from here, I'll jump inside, and in the palette, there's a section on TDAbleton. Choose the one that corresponds to your install. So if you have 9 and 10, choose the TDAbleton package there. Otherwise, 11 plus. And it'll give you this warning. It's like, oh, there's no Ableton to connect to. That's okay. We'll sort that out later. So I'll hit OK. Going to the parameters here, if you haven't installed it already, choose the version that you have. So probably Live 12 or 11. And only click this button if you do not have Ableton open. Otherwise, bad things could happen. So I think it even warns you. I'm not going to do it because I've already installed it, but click this button and it should add scripts to the appropriate folders. At that point, you can open up Ableton. I have it open already because I'm using it to record, and also have preset up a track for this purpose. So let's go ahead and go to our options. That's Control, comma, also the options and the settings. And under control surface, there's a great, you should just read the article too about setting this up, but you can just choose TouchDesigner and close it. I've already set this up so that it has the TD song, but it should automatically prompt you to add this. In fact, if I delete it, it warns me. This is actually from TouchDesigner, and it can create one. So it just automatically looks for this, and if it's not there, it will add the TDA master to your song. Cool. So I've pre-made this, and the example project has it. You can really use any synth or sampler that you like. One thing I recommend is, I'm using a scale MIDI effect here, setting it to Dorian, just because when you're triggering lots of sounds, if it's any pitch, this helps kind of keep it in one key. Hilariously, it could be any of these. So now if I play it, you get this kind of viola pits sound. And then I've added a shifter, just varies, detunes the pitch a little bit with a sine wave, and also this dub delay or dub echo. So it has kind of more character to it than just a really boring violin pits. Now, I'll leave it up to you to do more interesting things with the sound, but it's just a basic example. I want to show how you can trigger things. So yeah, there's the Ableton setup. The other thing, so let's go ahead and jump back to TouchDesigner. And now we've got a connected sine. That's good. And so we can go ahead and start triggering our sounds. Okay, now that we have TDAbleton installed, let's jump inside the TDAbleton package. You'll see the TDAbleton master, which, as it says here, needs to exist for your project, in your project for TDAbleton to work. And I want to point out on the common page, it's using the global op shortcut. And so one thing you'll see is you can only have one of these in your project since you can only have one operator with a global operator shortcut. But also that makes sense, right? We can only have one device connected to Ableton, and that goes for multiple TouchDesigner projects. So you can't have two TouchDesigner projects both running this. Really, it's like designed for there to be one operator talking to Ableton. The other thing about this global op shortcut is it is what allows these components to be copied anywhere in your project, which is pretty cool. So we can, they all point to op.TDAbleton to find the TDAbleton comp. I tend to try to keep them in one spot just to keep them organized, but you can really put them anywhere as long as you have one of these in your network. So I'm going to copy the Ableton MIDI 1, go up one layer, and this level I will be storing my MIDI, which I really only need one. So one thing I can do now is set the track to that MIDI track I created, Viola Pits, and it's looking for a TDA MIDI device. So if I click Pulse, it will add one, and it shows up here under Device. So looking good. We should see some things pop up here, like the device on value. Now if I go to Ableton, you'll see it's created this TDAbleton, TDA MIDI device. It has placed it on the right channel here, but it's also not, it's placed it after this scale device. And so I'm going to place it in front. That's just a gotcha. You'll probably catch it if you're going between the two softwares, honestly. But just, a call out that might happen. Might have to reorganize these because MIDI is coming out of this device. And if it was in front, it would not be running through any MIDI processing that you have. So let's jump back to TouchDesigner now that we see this is here and connected. And yeah, we've got this happening. I want to call out on the TDAbleton tab this help page. So if we click that, it should drop you here to the TDAbleton system components. And if we go to Ableton MIDI, this is our MIDI output. So our component, our Ableton MIDI component. And you'll notice it has this method send MIDI, which is looking for type and then followed by some amount of data. So in our instance, we want to send it note values. There are a number of other types we can send this, which includes your standard MIDI commands. But we want our note, which is going to be followed by a pitch and a velocity value. So this whole page has a lot of information about all of the different components. So I definitely suggest checking this out if you want to go further with TDAbleton. But we're going to be focusing on our Ableton MIDI. All right, so now that we have this set up, and we let's go up a layer, actually 2 layers. Before we do anything, let's make sure we toggle TDAbleton on. That's that like if statement. So this switches between our TouchDesigner audio and Ableton audio. So let's make sure we do that. And then also let's open up our bsolver callbacks. So that's where we're going to actually trigger our MIDI. So I'm opening that up here, and I'm going to dock this over to the left. So we have a view of our network as well. Gives us a little more room. So the first thing I want to do is point to that operator, just like we did with the audio TD. We want to create a TDAbleton operator, just so we can reference this throughout. And I also want my Ableton MIDI operator. So I will also create another variable called MIDI op, and I'll set that to TDAbleton.op Ableton MIDI 1. So that's inside of TDAbleton, and that way we can send this MIDI values by just doing MIDI op dot send MIDI. Now, in the same way that we have our pitch, low, high, and velocity, or volume, low, high, for our TD audio, let's do that for Ableton as well. So I'll right-click and customize the component. We want these to be integers and sets of 2. so they're a range. The first one I'm calling pitch range, and also velocity range, like VEL range. And let's give those some initial values. So just so that it's extreme enough to hear it, let's do 40 to 80, 90 for our pitch values, and say like 10 to 100 for our velocity. If you're familiar with MIDI, we're dealing with 7-bit values, so we have 128 or 0 to 127 values to work with. So we want to kind of plan accordingly with these values. So next we're going to create parameters to store our pitch and velocity range so we can access them quickly, just like we did for the audio TD portion. We'll have one for our MIDI pitch low and high, which is the, if we go back to our TouchDesigner, we'll see pitch range 1, pitch range 2, velocity range 1, just like the other one. We'll set those so that we can quickly grab those values. And at this point, we can scroll down and we have our if audio source equals 0, or equals. I'll say else, and this is where we can do our TDAbleton work. So when we toggle that switch, it will now go to this lower section instead of triggering the TouchDesigner audio. And the first thing I want to do is set up these same remap and clamp setup to get my MIDI velocity and pitch values. And I'll make this full screen just because these are pretty long. So for MIDI velocity, again, we're remapping the amplitude and using the velocity threshold and maximum to map it to velocity low and high, and then clamping that to velocity low and high. I'm also making sure I cast this as an integer for both, since our MIDI send method will not like a float value. So just making sure that we're actually sending an integer value. I'll also go ahead and create that send MIDI method. And it's a note. This is like the type of message. And then we're passing our pitch and our MIDI velocity. So that's pretty much all we need to do. If I save this, send it back to the right, and it won't do anything initially until we run that reset script, right? So Control-Alt-R. Ooh, what did we get? I think I made an error. Let's take a look. Oh, yep, look at that. Something happened here. So that got messed up. Let's try that again. There we go. Okay, it's working. So funny little typo, but yeah, we're getting really low values. So as they slow down, they should get not only they should get a little quieter. I might not be mapping velocity very intensely to volume in TouchDesigner or in Ableton, but we are getting much lower sounds as they go lower. So we could probably bring this up a little bit to like 60. Great, so that's working. Now I'm going to reset this just so they stop bopping around. The other thing we might want to do, and this is not really necessary for the example I set up, but you might be doing, different sounds that don't have envelopes that finish when they're triggered, right? So if you have a synth that has any kind of sustain, this will just stay on, right? Every time it triggers, your note's just going to hold. And so with MIDI, we also need to manage our note off values, which means sending a corresponding MIDI velocity of 0 whenever we send like a note on value, which is a non-zero velocity value. So how do we do this? Well, we can't just send it right afterwards. It won't really give it enough time to activate that note. But I think for our purposes, and you can certainly explore different ways to do this because it doesn't work for every instance, we can send a delayed script that just sends that note off value. So I will, in the TDAbleton area, in that component, create a text dat, and I'll call this note off. Make it red. And I'll right click. No, I'll go to parameters here. Set this to Python and edit this in Sublime Text. So what we want to do here is this is a script we'll run, and we want to pass in our pitch so that we know what note we want to turn off. And we can do that with the arguments. So args and then square bracket 0 means that first argument we pass this will be pitch. And then we'll do the same thing. We'll do that send MIDI method. And instead of like a velocity that's non-zero, we just send it to 0. So this will essentially send a note off for this corresponding pitch value. So I'll save that so it shows up here. And now let's go back to our Bullet Solver callbacks, and we want to also create like get that path to our note off script. So I'll do that right here. Note off equals TDAbleton.op note off. It's this operator. And then after we send our MIDI, let's go ahead and run that script and delay like 10 frames or so, right? So note off.run, we're passing it that same pitch and then delaying 10 frames. So after 10 frames, we'll turn off our note. So this really only works with sounds that like have an envelope that follow through. But if you want this to be longer, like this would be how you'd control the duration in frames of your sounds. And you can of course vary this or find other ways of doing this note off process. I've definitely done a lot with building more complicated chop networks that say trigger a MIDI note and then based on sort of other things that are happening determine the duration of those notes, right? So or maybe is something that's actually holding in visually that stops, that blinks for a certain amount of time. You can use that same information to say trigger a sound, turn it on and off. So this is an example where I just want to make a little ping, right? Has a very fixed duration, but you might need to, explore other ways of working with the note off logic. But yeah, I'll go ahead and save this. I mean, it's still going to work the same for this example, but if you're playing with any sort of synths that have or samples that have a sustain, then this should at least help work with that. And there we go. That's the end of the tutorial. I hope you got something out of it. We covered a lot of ground, starting with the bullet physics and render picking, and then following up with TouchDesigner audio and Ableton audio. So among all of those and how they tie together, I hope you find some inspiration, and thanks again for watching.